Find d sub x, which is just another way of notating a derivative, of negative 6x to the 10th minus 8 square root x minus 4 over x to the 5th power. So here's a few different ways where the power rule is used. And we'll take this term by term because anytime you have added and subtracted terms in a derivative or a function that you want to find a derivative for, you can do it term by term. So let's start off by taking the derivative of the first term. So this would be, I'll leave the 6 off to the side. And of course, you can do that in one step. You don't have to put the 6 off to the side. I just emphasize it. X to the 9th power. And then the next term, 8 square root of x. Well, square root's going to be a little bit trickier. We don't really have a specific rule to differentiate square roots. However, what we can do is we can express the square root of x as x to the 1/2 power, making it in a form such that the power rule will apply. So now we can bring our exponent down and subtract 1 from the exponent. And I'm going to write this out just to be careful, make sure I get the right values here. And the same is true of this next term. Again, instead of differentiating 4 over x to the 5th power, I'm going to take and rewrite it as minus 4x to the negative 5th power. Just make that a negative exponent. So now I have my coefficient of negative 4. I'm going to bring negative 5 down, and this is multiplying, so be careful. X to the negative 5 minus 1. So let's simplify here. 6 and 10, so that's going to be negative 60 x to the 9th. 8 over 2, so that's 4. 1/2 minus 1. If you think of it as 1/2 minus 2 halves, then it should make sense that this is x to the negative 1/2. Then plus 20 x to the negative 6. So negative 60 x to the 9th. I'm going to change this so that I don't have any negative exponents. So minus 4 over the square root of x plus 20 over x to the 6th power. And that's a perfect answer right there.